If you have ever wondered how a medium voltage circuit breaker works with the CRP panel, then this video is for you. So watch this video till the end, and we can see here. So this is our schematic, okay, and it's this schematic shows the control and protection circuit of a vacuum circuit breaker, which includes the closing and tripping circuits, okay, along with supervisory elements. So we can see here there are some relays, okay. So there is a standby earth fault relay, overcurrent and earth fault relay. So in the previous video we have seen that these relays were not present in the VCB schematic, the breaker schematic, but this is a control and relay panel schematic which includes both. So let's start with the closing circuit here. First we will see the continuous line. We will see the nodes. So here it is written that the continuous line indicates the circuit in circuit breaker and the dotted line indicates the circuit in control panel. So we can differentiate that, okay, by looking at it. And these are the continuous lines, and you can see here these are the dotted lines. So the dotted lines indicates the circuit in the CRP, okay. So we will focus on how this circuit ensure the safe operation and protect the system during faults. So we will see first the power supply. So this is the 110 volt DC power supply coming from the customer, and the power for this system comes from a 110 volt DC supply, which is connected via terminals which are labeled J3 and J4. You can see here J3 and J4 are the terminals, and there is a miniature circuit breaker MCB, a 16 ampere MCB is here, which is used to ensure the safety. Then this supply powers both the control and trip circuits, okay. We will see then the closed circuit, which is used to operate the breaker to close, which will allow the current to flow through the system, okay. So the closing operation starts with the remote close command coming from the initiator panel. So you can see here the remote close from initiator panel. So this command is generating from the initiator panel, okay. So you can locally close the breaker, which is, you can see here the local remote switch is given here. In the previous video we have seen how a local remote switch works. So the remote close command is coming from the initiator panel, okay. Then this command is energizing the relay K1 and which will initiate the VCB52 closing coil, okay. The coil is energized through the relay contacts and protective fuses like FC1 and FC2, which will cause the breaker to close. So this one is the FC2 fuse and the FC1 fuse, okay. So you can see there are also the interlocks used here, which was the 94 is the anti-bumping relay, okay. And here one more thing is used, which is a T1. It's a timer, and there is also a timer contact used. T1, this one is the timer contact, which is a changeover contact, and this one is the timer supply contacts, okay. And the VCB52 is the closing coil. There is also some elements used like ZZ switch and 95 trip circuit healthy contact. It's a NO contact, okay. So 95 is the trip circuit healthy indication, okay. So we will see the tripping circuit now. So the tripping circuit is responsible for opening the breaker when there is a fault or when a trip signal is received, okay. The remote trip command comes from the same initiator panel. You can see here. So same initiator panel sends the command to close and trip the breaker. There is also a trip circuit supervision relay, okay. You can see here this one is the trip circuit supervision relay, okay, which will monitor the healthy trip circuit. If the trip circuit fails, then it will generate an alarm. We will see the protection relays. Here are the protection relays. So in this schematic, several protection relays are used to monitor the system and initiate the tripping command during faults. Okay, so we will see first, this one is the standby earth fault trip. Okay, so it's a standby earth relays in a contact 64N, and the 5150 is the overcurrent and earth fault trip. Okay, so this overcurrent relay protects the system by tripping during overcurrent or earth fault conditions. And there is also a OV and UV trip. This one is used when this relay trips the breaker if there is an issue with the voltage levels. If the voltage goes above the rated voltage or it is going below the rated voltage, then it will generate a trip command to trip the breaker. Then there are some supervisory circuits. Okay, the supervisory section checks the health of the DC supply and the other circuit elements. Okay, so DC supervision contactor checks the health of the control supply. If the DC supply is lost, then the supervision circuit sends an alarm. The auxiliary supply ensures that the protective relays have power to function. Okay, so this one is the DC supply check element from DC fail unit. So this one is the DC fail relay. Then 98D is the DC supervision contactor. Okay, and all the relays they have got the DC supply from here, auxiliary supply for overcurrent, and which is a REF relay. It's a residual earth fault relay, and auxiliary supply for under voltage and over voltage relay. So these are the supply. So all the relays get the supply from here, and you can see here there is also a contact named RTTB. So RTTB is the relay test terminal block. Okay, so electrical reset type master relay. So electrically reset means we can reset the master trip relay electrically. And how it will reset? It will reset by this contact. So there is a push button given here, provision for remote reset. You can remotely reset the master trip relay or by just pushing this push button. Okay, so this one is also used for local tripping or locally. Then this is the same circuit as we seen in the first schematic of circuit breaker, but the only difference is there are several relays used here, and there is a timer and 95 trip circuit healthy contact is externally used here. Okay, so this is how it will work. If there is a fault, then this contact will get NC and trip coil will get a supply. Okay, so if there is any fault in the system, then this contact the relay will sense the overcurrent and it will send a command from this contact to the electrical type master relay, and the master trip relay will operate the trip coil and it will lock out the circuit breaker. Okay, so this is how the circuit breaker will trip by using the relay. So this is the video. Hope you learned something from this video, and if you want to learn more, then do comment. I'll definitely make a video on it.